So today we are going to read about a new topic, that is, what did I write here? What did I write?
D'Alembert's principle.
D'Alembert principle.
Yeah,
D'Alembert's
D.
principle.
Alembert's principle. Okay, this is very, very important. Basically, this question comes for 2 marks. Is this clear? State D. Alembert's principle. Okay. So, what actually is this principle? Uh, what is Newton's second law? What is Newton's second law? Yes.
That the rate of change of momentum is directly proportional to the force applied with it with respect to time.
Okay. We say that F is equal to mass into acceleration or not?
Yes, sir.
So, this was the empirical expression which was given by Newton, that F is equal to m into A. So, basically, when we try to explain this, whenever a force is applied on a particular mass, when you're applying a force on a particular body which is having a mass, clear, that particular body will accelerate with an acceleration A. Okay. So when we talk about this, that means the body is moving, is it? So the body is in which state? It is in dynamic equilibrium state. All of you are clear? So the body is in a dynamic equilibrium state. That means this particular body is actually moving. Okay. All of you are clear? So F is equal to ma states that the body is in dynamic equilibrium. Somebody should answer. Okay. Very important, you see. Now F is equal to mass into acceleration. Force is equal to mass into acceleration means that particular body is there in a dynamic equilibrium state. Okay. So one fine morning, this person who named as D'Alembert's principle, he saw this expression. And simply what he has done is F minus ma is equal to 0, he has written. Is there any wrong in this?
No, sir.
No, sir.
Ma he has taken to the other side and he has written equal to 0. Okay. So Newton also never thought about this particular thing. So D'Alembert, he came and he said that F minus ma equal to 0. And you already know, whenever this equal to 0 comes into picture, so the body is in which state?
Static.
Static. Clear? So what he is actually trying to say is, any body whichever is in motion, you can bring that particular body which is in motion to static position. Can you bring it or not? Any body which is in motion, can you bring it in the
Yes, sir.
in static position or not? So how can
Yes,
you bring
sir.
that particular body in
Yes,
static
sir.
position?
Yes,
Suppose
sir.
a person is coming towards you. When a person is that
Applying
particular,
forces upon
yeah,
applying force in opposite direction.
opposite direction. Suppose a person is running again, is running and coming in towards you. So if you want to stop him, clear, that particular person has a particular mass or not? So he's coming with some acceleration. So his mass into acceleration, if you multiply, that much of force you have to apply in the opposite direction, then only you can stop him, and that particular body can be in static equilibrium or not. So F minus ma equal to 0. This is given by D'Alembert's principle. So in other way, what he has written, you can also write this way also. F plus minus of ma equal to 0. Can I write this in this way? Can I write it or not?
Yes, sir.
Yes, sir.
F plus minus of ma equal to 0. Okay. Now let me ask you one particular question here. Either you can follow this particular equation f minus ma equal to 0 or f plus minus of ma equal to 0. It is up to you. Now you decide while solving the problem. You decide while solving the problem, let us take f minus ma equal to 0 or f plus minus of ma equal to 0. Now you say me, if there are two forces, F1 and F2, if I am writing the algebraic sum as F1 plus F2 is equal to 0, what does it mean? These two forces, you mean that whenever there is a positive sign, both are positive, you say that both are in same direction or not? Both are in same direction or not? Yes or no? Both the forces are in same direction.
Same direction.
Are you getting? Now here F plus minus of ma. Now here minus of ma is what? Minus of ma is the inertia force. Minus of ma is the inertia force. So what I mean to say is, if you are considering this particular equation F minus ma equal to 0, that means the net force which is responsible for the motion of the body, clear, minus inertia force is equal to 0. That means inertia force is applied in the opposite direction. Inertia force is applied in the opposite direction to make the body at rest. Now if you are going to apply this particular equation, you can either use this or this, it's up to you. If you are using this particular equation, inertia force is applied in the same direction, but it should be minus inertia force, minus of ma, because it is a plus sign, so both are in the same direction. Did you get my point? All of you?
Yes, sir.
Now you will understand while I give you certain examples. So whenever D'Alembert's principle comes to your mind, clear? So if he asks what is D'Alembert's principle, you can simply write in this way. Just I am writing the definition. D'Alembert's principle states that a dynamic equilibrium problem can be converted to a static equilibrium problem. Clear? What is the D'Alembert's principle? It states that a dynamic equilibrium problem, that means dynamic equilibrium problem means a body which is in motion, is converted to which problem?
Static equilibrium
Static
problem.
equilibrium problem. So as I told you, if somebody is running, if you want to stop him, how will you stop? You apply the opposing force. Now, what is that opposing force? That opposing force should be nothing but the inertia force. That is mass into acceleration. His mass you multiply with what acceleration is coming. If that much amount of force, if you are able to apply on the body will be in equilibrium. Understood? The body will come to rest. Now there is a question in your mind that that particular inertia force should be applied in opposite direction or in which direction you have to apply. Is this clear? if you are applying the inertia force in the opposite direction, you have to use this particular equation. What is that equation? F minus ma equal to 0 to solve the problem. If you want to apply the inertia force in the same direction, then you have to apply this equation, F plus minus of ma equal to 0. Got my point? All of you are
Yes,
clear?
sir.
Okay. Yes. I'm giving you an example. This is a body which is there on a which surface?
Rough surface.
Rough surface. Okay. Clear? Or you take it as smooth for the time being. Now here which force you are applying on the body? Suppose you are applying a pull force here. Okay. Now as here there is one contact surface, one normal reaction will be there or not? There will be one
Yes,
normal
sir.
reaction or not?
Yes, sir.
Yes or no? Now here
Yes, sir.
when you are applying the force, the body will move in which direction you say? The body will move towards right side or not? The body will
Yes,
move
sir.
towards right side or not? This is the direction of motion or not? If you
Yes, sir.
if you want to stop this particular body, now this particular body is in dynamic equilibrium state because the body is moving. If you want to bring this body to static position, you have to apply which force? You have to apply the inertia force. Which force you have to apply? The inertia force.
Inertia.
Mass into acceleration. Because here it is given in terms of weight, so the inertia force will be what? Can anyone say? It will be W by G into A. W by G into A. That is mass into
A.
acceleration.
Absolutely.
Clear? So here what I am trying to say is, here comes the direction. Now what are the two equations I told you you can use? One is F minus ma equal to 0. What does this mean? Force and inertia force are opposite to each other or not? Yes or no? Force and inertia force are
Yes,
opposite
sir.
to each other. Then only the algebraic
Yes, sir.
sum will be in this format or not? F minus ma equal to 0. Okay. So this is F is positive and this side is negative. So you see now F minus W by G into A is equal to 0. Is it correct?
Yes, sir.
Now the body has come to
Yes,
static.
sir.
Now the body has come to static position or not? Why the body has come to static position? Because you are applying the inertia force in. Now this is the direction of motion in right side direction, and towards the opposite direction you have to apply the inertia force. Then the body will come to static position. It will come to rest. Got my point? Is this clear?
Sir.
Yes, sir.
Now
Yes, sir.
you can also do in this way also. All of you see. Now what is the direction of motion? What is the direction of motion? Again same, towards right side. Clear? Suppose instead of this equation, suppose you want to apply this equation, W plus minus W by G into A equal to 0. That is nothing but F plus minus of MA equal to 0. This equation I have written in the starting. I will put plus sign. What does plus sign indicates? Both are in same direction. So here you see the direction is W by G into A. Now when I change the direction, this will become minus W by G into A or not? Yes or no?
Yes, sir.
Now you see
Yes, sir.
F both are in same direction. F plus minus W by G into A equal to 0. Now it is up to you whether you consider this or this while solving the problems. Which one you want to consider, you say now. Which one? The first one or second one?
Second.
All of you agree with this?
The second.
Second one.
Second one.
Okay.
Yes, sir.
We will take the second one. Okay. That means both the force and the inertia force are in same direction. But one thing you remember, if both are in same direction, if you want to take it, inertia force will be negative or positive? It is negative.
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 That you should be very careful. Got my point?
Yes, sir.
Okay.
Yes, sir.
Now let me give you one more example where you can understand. Now here there is a pulley where one end of the pulley we have this weight P, and on the other end there is a weight Q. Can you see this, all of you?
Yes, sir.
Can you see it? Okay. Now here how many bodies are there? There are two bodies here.
Two.
Okay. So let us take free body diagram of the first body, that is the body P. Clear? Now assume here, you try to assume that Q is greater than P. If Q is greater than P, what will happen? Can anyone say? If Q is greater than P, so Q will go in which direction?
Upward.
Q is greater than P. So Q will accelerate in which direction? Downward direction.
Downward.
Downward.
And P will accelerate in which direction?
Upward.
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 Direction. Okay. So here the tensile force will be as it is because it is a single string, that is T and T. Okay. Now when you draw the free body diagram of P and free body diagram of Q, let us draw here now. Now for P, the weight always acts in which direction? Downward direction.
Vertically
Okay.
downward.
Vertically downward. And tensile force in which direction? In the upward direction. Q also, weight always acts vertically downward, and T will be in this upward direction. Any doubts?
No,
No,
sir.
sir.
Now Q is going in which direction? Q is
Downward.
going in downward direction. Now this is a dynamic equilibrium problem. Now if you want to
Downward.
stop, okay, if you want to stop Q, if you want to bring this in static position, inertia force should be applied in which direction? Yes, inertia force should be
Upward.
applied in which direction?
Upward.
Upward.
Upward direction.
Upward.
So
Upward direction.
let us apply in upward direction. If it is upward, I told you if both are opposite, you have to take how much? Q by G into A. Understood? Let us take the first equation so that your concept will be clear. Is this clear? All of you are clear?
Yes, sir.
Or you can do the same diagram in this way also. Downward direction you can take, but this will be minus Q by G into A. Any doubts?
No, sir.
Okay. Similarly, for this, the weight acts vertically downward. Okay. And here the tension is there. Now this P is accelerating in which direction? Upward direction. So if you want to
Upward.
stop the body, inertia force should be in which direction?
Downward.
Downward direction. How much?
P by G into A.
Understood? Okay. So these two things which you have considered, clear? This is in accordance with this particular equation, F minus W by G is equal into A equal to 0. And these two which you have written, this is in accordance with the equation F plus minus W by G into A equal to 0. Understood? Now it is up to you. Clear? Here it is down, because this is accelerating in upward direction. You are putting the inertia force in the downward direction. Suppose this downward direction, if you want to take in upward direction, this will become minus P by G into A. All of you are clear? Are you understanding?
Yes, sir. Yes, sir.
Yes, sir.
Now let me ask you one more question, then we'll go for solving the problem. Suppose this is a body which is there on a rough horizontal surface. Which surface? Rough horizontal surface. Okay.
Rough horizontal.
Hmm. Now, the weight always acts in which direction? Vertically downward,
Vertically downward.
and this will be the normal reaction. Okay. Now
Normal.
the question is, here the body is deaccelerating. What is happening here? Anyone? The body is deaccelerating, and finally it is coming to 0. Finally it is coming to rest. Now can you say the body is deaccelerating? You are not applying any kind of external force here, please. The body is deaccelerating in which direction? Towards right side, and finally it is coming to 0. Can you say why it is coming to 0? By virtue of what? By virtue of frictional force. Because it is a rough surface,
DS
no?
plus.
Because it is a rough surface, because of frictional force, the body will come to rest. Got it? Because it is deaccelerating in this position, frictional force will be opposite or not? F is equal to mu into N. Understood? Understood or not?
Yes,
Now,
sir.
the frictional
Yes,
force
sir.
is in this direction. Now my question is, okay, this particular minus of A, which I have written here, clear? Can I change its direction in opposite direction, and can I write it as A? Simple.
Yes, sir.
Force. Can I write it? Now, when this body is moving
Yes,
in
sir.
this, when the body is moving in this direction, it is accelerating towards left side or not? Now the body is going towards which side? Towards left side. Now if you want to stop the, if you want to stop the body, inertia force should be applied in which direction?
Right side.
Towards right side. What is the
What
inertia
side?
force? W by G into A.
Yeah.
Is this clear? Is this clear
Yes,
to
sir.
you? Now the same thing you can write
Yes,
in,
sir.
you can draw the diagram in other way also. All of you please see. There is a weight acting vertically downward. Normal reaction is upward, perpendicular to the contact surface. And this is the negative acceleration. And this is your, which force? Frictional force. Okay. Sir, I don't want to change the direction of A. From minus A to A, I won't consider. I will take minus A. If you take minus A, it is going in which direction? Towards right side.
What side, sir?
If you want to stop the body, in which direction inertia force should be applied?
Left side.
Towards left side. But here you should be very careful. It should be W by G into minus A. Understood? Understood? Now both the
Yes.
diagrams are the same or not? This is W by G into A, If you change the direction of this, it becomes minus W by G into A or not. So D'Alembert's principle totally depends upon in which direction it is accelerating. If you are accelerating towards right side, if I want to stop you, I will apply towards left side to stop you, to make it in static position. Towards opposite side, I will apply the inertia force. That is called as the D'Alembert's principle. Is this clear?
Yes, sir.
Now
Yes, sir.
let us do some problems. Okay. So whenever you get a problem, he will simply say use D'Alembert's principle. So then only you'll use this D'Alembert's principle. Clearly it will be mentioned in the question. Okay. So here the question is, what is the question? Two weights P and Q are connected by the arrangement as shown in the figure. The figure will be given to you. Neglecting friction and inertia of the pulleys and cord. Cord means the string. Find the acceleration of weight Q. Okay. Assume P is equal to 178 Newton and Q is equal to 133.5 Newton. Is this clear?
Yes, sir.
What is the question? Two weights P and Q. Are connected.
It's P and Q connected by
The arrangement.
arrangement as shown in the figure,
Okay.
neglecting friction and inertia uh,
Neglecting friction and inertia of the pulleys.
inertia pulleys and cord.
Cord
Find
means
the
cord means string.
string is
Okay.
find the acceleration and weight Q. Assume P assume P pulley
Assume P is equal to
170 Newton,
178.
78 Newton, Q
Q is equal
total.
to 133.5. Okay.
Yes, sir.
Why people are still joining? Clear?
Yes, sir.
Now Now this is the diagram that is given to you. This is P and this is Q. Okay. And in the diagram, it is clearly written that Q is accelerating in downward direction. It is given in the diagram. Okay. So Q is accelerating in which direction? Downward direction.
Downward direction.
Okay. So you have to find out what is the acceleration of that particular weight Q, which is in downward direction. Clear? So here you have to use the D'Alembert's principle. Here in this question I have not given, but this question is solved using D'Alembert's principle. So let us solve. Now you know that this is a single string or not? All of you. This is a single string. Okay. So you know that in this cord, the tensile force will be there. This is the tensile force and this is the tensile force. Any doubts in the tensile force? The cord is a single cord. It is a single string.
No, sir.
Is this clear? Now, Q is moving in which direction?
Yes, sir.
Q is moving in which direction? Downward direction. Okay. So, I told you.
Yes, sir, down direction.
Yeah, it is given in the question. So, free body diagram of P and free body diagram of Q. Okay. Now, if this is going with an acceleration A in downward direction, in the previous class I told you, this P will go in which direction? If Q is going in downward direction, P will go in which direction?
Upward.
Upward direction. What will be the acceleration? I told you, na, if
A by 2.
yeah, this is A by 2. Good. If this is going with acceleration A, this will go with A by 2. Understood? Now, to confuse you, he will say that this is moving with an acceleration A by 2. So, this will be how much? Instead of A, he will say A by 2.
A by 4.
This will be A by 4. Okay. So, in that way, you have to solve it. Now, let us draw the free body diagram. Okay. So, P acts in which direction? Weight always acts in vertically downward. Understood? Now, in case of P, you see, in case of P, what will be the tensile force? Anyone? What will be the tensile force?
2T.
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 2T. Very good. In case of Q, what will be the tensile force?
T.
It will be T.
T.
Okay. So, Q is going in which direction? Q is accelerating in which direction?
Downward.
Downward direction. P is accelerating in which direction?
Upward.
Upward direction. That you should write it in this free body diagram. So, and confusion. Understood? Now, this is going in downward direction. Okay. When you apply D'Alembert's principle, you have to apply the inertia force in which direction? So that this body, see, this body is going in downward
Upward.
direction. Okay, inertia force will be
Upward.
applied in upward direction. I don't have place here.
Upward.
Can I put here?
Yes, sir.
Q by G into A. Understood? Now the body is in equilibrium. Okay. Now here the body is going in which direction? P.
Upward.
A by 2. So in order to stop P, to make it static, inertia force is applied in which direction?
Downward.
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 How much it is? P by G into
Into
By
A
2.
by 2.
A by 2. Understood? If this you have done, then your problem is 80% finished. Okay. Now let us see for this particular body one by one. For this particular body, that is a free body diagram of P. When you consider free body diagram of P, clear? Can you see what is the equation here? Can anyone say? 2T is in which direction? Upward direction. These two are in downward direction or not? You know that upward force is equal to, now this has become static or not?
Downward.
In static force,
Downward force.
in statics, upward force is equal to downward force. So 2T is equal to P by G into A by 2 plus P. Is it correct?
Yes, sir.
Okay. So this is equation 1. Now what is equation 2 here? Upward force is equal to downward force. Again, T plus
Q by GA.
A equal to Q.
Q.
This is equation 2. Okay. Now what you do is, better you do one thing. In equation 2 you write in much more simple way. T is equal to Q minus Q by G into A. Is it correct?
Yes, sir.
Substitute this value of T in equation 1. So what will be the equation? 2 into Q minus Q by G into A is equal to P by G into A by 2 plus P. Is it correct?
Yes, sir.
Already you have the value. What is the value? I am writing here. P is given as 178 Newton and Q is 133.5 Newton
133.5.
given in the question. Now let us substitute all these values. 2 into Q is 133.5 minus 133.5 by 9.81 into A is equal to 178 by 9.81, clear, into A into 2, is it, plus 178, clear. Somebody solve it. So let me solve, let me take the calculator. You can also do it. Okay, it was 133.5 divided by 9.81. Okay. So 267. Okay, I'm doing the calculation in the calculator.
13.60.
Okay, you see whether it is correct or not. Is it correct? You verify.
Yes, sir.
I'm doing direct calculation. You will get A is equal to 2.45 meter per second square. Is it correct? Are you getting? 260. I'm doing in front of you, you see. 89 divided by 9.072 plus 57.21. Is it correct or not? You see the answer I got. Can you see the calculator, all of you?
Yes, sir.
2.45 meter per second square. Verify, huh?
Yes, sir.
Yeah. This is how you solve by using D'Alembert's principle. See, it's simple. D'Alembert's principle, what you do is, in the opposite direction, opposite to the direction of motion, you apply the inertia force to stop the body. So mainly the concept of D'Alembert's principle is a dynamic problem is converted to a static problem. Understood the concept, all of you, D'Alembert's principle?
Yes, sir.
Is this clear? All of you understood?
Yes, sir.
Okay. We'll stop here. Maybe tomorrow we'll solve some more problems. Okay. Maybe I will be solving some more problems on D'Alembert's principle and I will be sharing it with you. Do you have any doubts in the morning? The link which I have shared,
Okay, sir.
that particular problem which I have shared in the morning.
No, sir.
Please do it. Huh?
Yes, sir.
Okay. Is there any doubt here? I think everybody is clear with this.
Yes, sir.
Q is, again I am
Yes,
explaining
sir.
Q is going in downward direction. Okay. Q is going in downward direction. It's accelerating in downward direction given in the question. So if you want to stop this particular Q, you have to apply the inertia force in upward direction. Inertia force is nothing but mass into acceleration. That is W by G into A. See, in opposite direction I have applied. But P is going in upward direction because Q, if it goes, see, in the question it will be given only the direction of one weight, in which direction it is accelerating. As Q is accelerating in downward, P will accelerate in upward direction. So here P is accelerating in upward direction, that is A by 2 acceleration. So you have to apply the inertia force in the opposite direction of acceleration. So that is why I applied in opposite direction. You see, acceleration and force, inertia force, are opposite to each other. Got my point? Then only you can make the body in static equilibrium. So once it becomes static, you know upward force is equal to downward force. In that way, you're doing this equation and solving it and getting the final value of A. Okay? Mainly, in this D'Alembert's principle, mainly they will ask you in the question what is the acceleration or what is the tension. Okay, they won't ask you any other parameter. Clear? And this question which I have solved now is very, very important. Okay.